This exercise 12.2 of the chapter surface area and a volume. The first problem in this exercise is a solid is in the shape of a cone standing on a hemisphere. So first we will analyze what is the question. Here the question is given as a solid is in the shape of a cone. One solid is there, it is in the shape of a cone, which I have drawn here, and it is cone standing on a hemisphere. This cone is standing over the hemisphere with both the radii being equals to 1 centimeter and the height of a cone is equals to its radii. So both the cone and the hemisphere radii is 1 centimeter. The height of a cone is same as the radii. So that means it is 1 centimeter only. Find the volume of the solid in the terms of pi. The volume should be find out, but the answer is we should not substitute the value of pi. We should keep the value answer in the form of pi. So what we will do? We have height is equals to r is equals to 1 centimeter. Next, what we have to calculate? Volume of solid. Overall, this all together we call it as solid. Cone plus this cylinder, this is solid. The volume of a solid is equals to volume of cone plus volume of hemisphere, the hemisphere volume. So this together forms the total volume of total capacity of a solid, given solid. So what we do? We will split it like this. First we will calculate the cone volume, then we will add the volume of hemisphere. So volume formula I have given already. So here we have to write the volume formula. The volume of a solid is equals to volume of a cone. Volume of a cone is 1/3 pi r square h plus volume of hemisphere is 2/3 pi r cube. Clear? Now what is the value of r? R is 1, h is 1. So both are 1. So we will write it as pi into 1 square into h. H is 1 plus 2/3 pi into 1 cube. So our answer is 1 into 1 will be 1. Pi by 3 plus 2 pi. Pi into 1 cube is pi only. So pi. When we take it LCM, 3 pi. This cancel, we will get pi centimeter cube. So our answer is pi centimeter cube. So our answer will be pi centimeter cube. Is it clear, everybody? So this was the first problem. Let's move to the second problem. What is the second problem? So same exercise 12.2. The second problem is an engineering student asked to make a model shaped like a cylinder with 2 cones attached to it. So it has been Rachel student, engineering student. He is an engineering student. What he has to do? He has to make a model. Engineering student was asked to make a model shapes like a cylinder. It should be like a cylindrical shape. Clear? So with cylindrical shape with 2 cones attached to the 2 ends. Cylindrical shape with 2 cones attached to the 2. This is a 2 cones attached to the cone, and the cylinder is 3 centimeters. This is 2 centimeters. And the diameter of a model is, this model diameter is 3 centimeter and the length is 12 centimeter. This overall model length is 12 centimeters. If each cone is of height, this each side the cone is attached, their cone height is 2 centimeters. This side, 2 centimeters, and this. So what we have to calculate? Find the volume of air contained in the model. This model, how much is the air contained? Volume we have to find out. So solution. What we will do? Solution part. So let's start solving. So first of all, what we will do? Diameter D is equals to 3 centimeters, R is equals to 3 by 2. H1 we will take it for the cone, height of cone. There are two heights for the cone height, and H2 is for cylinder height. So we will take 2 for the cone, H1 for the cone, that is 2. Total height of a solid is, total height of this shape is, or the model, total height of the model is 12 centimeters. We don't know the height of a cylinder, so we can calculate this height of a cylinder, that is total height minus each side there are the two cones, that is 2 plus 2 4. So 12 minus 4, you get the height of a cylinder like this. If we subtract this part and this part, the remaining height will be of cylinder. So what we will do? We will write it like this. H2 is the cylinder height. Cylinder height. So what we will do? We will write 12 minus 2, that will be your 8 centimeters. 8 centimeter is the height of your cylinder. Next thing, what we have to do is volume of air. Inside this model, what is the volume of air? So what can we do? We have to find out the volume of cylinder. We have to find out the volume of cylinder plus, as there are the two cones, so we can multiply 2 into volume of cone. They are the two cones, so we have multiplied the volume of cone into 2. Instead of writing repeatedly to volume of cone, I have multiplied it. So volume of a cylinder is pi r square H2 plus 2 into 1 by 3. Volume of cone is 1 by 3 pi r square H. If we take pi r square common, we got H2 plus 2 by 3 as 2 into 2 by 3 into H1, cone H1. So we will substitute the values. If we substitute the values, that is 22 by 7 into R is how much we got? R is 3 by 2, correct? 3 by 2 square. So we will write 2 times 3 by 2 into H is how much? H2 is how much? H2 is 8. 8 plus 2 by 3 into 2. So what we have to do is, we will 1 so what we will get? 11 into 9 by 7 into 2. 7 2s. Okay. Next, what we can do here is, we can take this part as LCM. What we will do? 8 we will write as it is. So what we can do is, okay, 2 2s are 4. I will keep it now, for now, as it is, 4 by 3. Now next step, we will solve it by taking the LCM. So 11. So 11 into 9 by 7 into 2. 8 3 8s are 24. We can take LCM plus 4 by 3. So it will be 28. So 11 into 9 by 7 into 2. 11 into 9 by 7 into 2 into 28 by 3. So 7 1s are 7 4s are, right? 2 1s are 2 2s are, 3 1s are 3 3s are. So what is this remaining over here? 11 into only 11, 3 2s are 3, only 3 inside the bracket 2, so 3 2s are 6, so 11 into 6 will be 66 centimeter cube is your answer. So the volume of the air inside this model is 66 centimeter cube. Is it clear?